Hello everyone. In this video we're going to be doing some 2.5 axis machining in VisualCAMc, our full production cloud CAM solution for Onshape. And what I'm going to do here is we've got the VisualCAMc for Onshape running, and I'm going to go ahead and load my part document for my Onshape document. So here is my part, and it looks like I've got a little bit of it done already. So let's go ahead and complete the setup portion. Let's go ahead and check our machine. We see that it's set, our Z-axis is set to the top. That's what we want. X is to the right, to the long ways of the part, and Y is to the back of the part. So that's okay. Let's go ahead and set our post. We've got Haas selected, and if you want to load from over 300 other posts, you can select load from defaults. So go ahead and close that. Our stock is defined as a part box stock, and we've got 100 thousandths added to the X and the Y and the Z for machining. And for our setup, it is currently aligned with our machine, which is Z-axis up, X-axis to the right, Y-axis to the back, and that's what we want. And we also have a work 0 defined, and currently it's located at the stock box, at the highest Z face, and in the southwest corner. And you'll see that this moved our machining coordinate system that was aligned with our world axis in Onshape up to this point on our stock. So we've got the part set up. Let's go ahead and do some 2.5 axis machining. We're going to do first a facing operation on the top of this part to face it down to spec. So we'll go up to 2.5 axis facing. And one thing I wanted to do here, before we do that, let me pop over to the Tools tab and show you that we have a tool library loaded down below. And this tool library is actually, the library file is actually located in this part under the library folder. If you go to the library folder, you'll see the worm gear housing CSV file, and you just download that file. And then you just download that file, and then you load it right into here directly and drag and drop your tools up into your current document. So we've already done that. So let's hop over here to the machining job. This is our top facing operation. Let's go ahead and name this top face. And we'll select one of our tools. We'll use our 2-inch facing mill. Feeds and speeds, we'll let those set to defaults. Clearance, we'll let that set to defaults. For the parameters, we'll adjust this, and the stock, it doesn't apply to facing, it's just on the sidewalls, and there's no sidewalls on the top of this part, so we'll leave that set to 0. And for the offset direction, we'll leave that set to 25% of the tool diameter. For the cut levels, let's go ahead and select some geometry. Now, we want to cut the top of this part, but we want to face it all the way around. So we're going to select the bottom, right-click and select the bottom edge perimeter all the way around the part. For the location of cut geometry, we're going to pick the top of our cut, and we're going to say the top of our cut is going to start at 0. And then we're going to cut down 0.1, which is how much we added to the top of our part for stock. And we'll go ahead and do that in 2 levels. And for entry and exit, we'll use lines and arcs. And for the exit, we'll just leave it set to none. And for arc fitting, we'll set our tolerance, and we'll do arc cut rounding, and let's generate. So here you see you've got our facing operation for the top of the part. We've got 2 levels, and we've got a 25% step over. We've got corner rounding turned on. So let's go ahead and simulate this. Okay, if you want to turn the toolpath off while it's simulating, and slow that down just a bit. Okay, there's our facing operation. Now, what do we want to do next? Let's go ahead and do some 3.5 axis roughing to clear out some material in here that we can get to. So let's go ahead and go to 3 axis, Z-level roughing. We'll leave our bottom perimeter selected as our containment. For the tool, we'll select the 1/2 inch flat mill. Feeds and speeds, we'll leave those set to the same, clearance the same. For the parameters, we're going to set this to 10 thousandths, and we'll leave 25 thousandths of stock. We'll use the high-speed cut pattern, and we'll do a cleanup pass at each cut level, and we'll do a step down of 1/8 of an inch. And for the core facing areas, we'll do a step over of 40%. Corner cleanup. Change that to 40%. For the cut levels, we'll set that to 1/8 of an inch step down. And we'll do a depth first, means it's going to cut all the way down on each one of these pockets. And we're going to clear the flats, so that it's going to put a toolpath right on this flat area to machine that right down to spec. For entry and exit, we'll use a helical entry, and we'll use a linear extension on our exit, and we'll perform some arc fitting. And let's generate this and turn our toolpaths on. So here's our nice high-speed pocketing cut pattern in levels. And what we'll do is we're going to go through all of the toolpath operations, and then we're going to simulate them together at the end. So let's go ahead and do, let's turn that off for a second. So we've got our roughing. Let's go ahead and do some profiling on these front edges of the part. Go ahead and 2.5 axis profiling. For our regions, we're going to hit the space bar to deselect, and then we're going to select these regions here on each side. Okay, so there's the regions we want to profile out. For the tool, we're going to use the same flat mill, and then for the parameters, tolerance is 1,000, stock is 0, so we're going to finish it right up to the face of the part. And we'll use a climb cut direction, and we're going to let VisualCAMc determine the side to cut. Total cut width is 0, so it's going to make one pass at multiple levels. For our cut levels, where's our geometry? It's at the bottom, and the total cut depth is 1 inch. And for the rough depth per cut, we're going to divide that up into 1/4 inch depths, and we'll do depth first, so it's going to do one profiling and then go and do the other. So for entry and exit, we'll leave it set to lines and arcs. We'll apply the entry and exit at each cut level, and for the we'll leave the same for the exit, and we'll set our arc fitting, and let's generate. So here you see our 2.5 axis profiling operation on each of these sides. And you'll notice that since we set the entry and exit at each cut level, and we set it to a climb cut direction, you'll see that it enters and then exit, and then it'll retract and do another level, and we'll get a nice clean cut on that profile. So what do we want to do next? For now, let's go and finish this back pocket. That'll be a 3-axis finishing operation. So go to 3-axis and we use parallel finishing on that. And for the geometry, we're going to select these 4 edges here. Now we're going to use a 1/4-inch ball mill, which is going to cut this fillet for us. So we're only going up to the edge of the fillet, and the ball mill will cut the fillet. And feeds and speeds, we'll let those set to the defaults. For the parameters, a 1/1000th for the in tolerance, 1/1000th for the out tolerance. Stock is 0, so we're going to finish it right up to the part. We'll use a mixed cut direction. For the angle of cuts, the 0 direction is along the X, so we'll leave that at 0 to match the long side of our cut. And we'll go ahead and set a step distance of 0.05 thousandths. So we're going to get a really fine finish on that. So let's go ahead, and we don't need any Z containment. We'll leave the entry and exit to linear. We don't need sorting. Let's go ahead and set our arc fitting. And let's go ahead and generate that. So there's our really nice 5 thousandths step over for this pocket. Okay, so let's go ahead, and we've got the pocket done. Let's go ahead and finish this outer pocket, front pocket area. The face here is already finished from the roughing operation because we picked the clear flats option, so it's cut all the way down to that surface already. All we need is a profile to clean this out. So let's go ahead and do 2.5 axis profiling. And we'll clear our selections, and we'll do a right click and select this outer area here. For the tool, we'll use our same 1/4-inch ball mill. For the parameters, our tolerance is 1/1000th, our stock is 0. We're going to finish it right up to the face. And we're going to use a climb cut direction. We're going to determine using 3D model for the cut start side. Total cut width is 0, so it's going to take 1 pass at multiple levels. So our location of cut geometry is at the top, and the cut depth for this pocket area is 1/2 inch. And we're going to set this at 1/8 inch increments. And we're going to do depth first, where we only have one profile, so that depth and level doesn't apply here. So for the entry and exit, we're going to use lines and arcs. And we're going to apply this at each cut level, similar to our profiling on this front side. And we'll go ahead and do our exit the same. And we'll set the arc fitting, and then we'll generate. So you'll see a profiling operation that does the entry and exit for each level, and it'll come back over and do the next cut and finish that real nice down to our face, top face of the pocket. So what have we got now? We've got the pocket finished out. We've got these areas finished out. Let's go ahead and do some drilling for these holes. So we'll go ahead and 2.5 axis. And well, before we do the drilling, this one pocket in the middle, we're going to use a pocketing operation since it's not the same diameter as these other holes. So let's go ahead and do a pocketing. We'll spacebar to deselect, and we'll select this diameter right here. And for the tool, we're going to use a smaller 1/4 inch flat mill. And for the parameters, our tolerance is going to be 1/1000th. Our stock is going to be 0. We're going to finish it right up to the side walls of the hole. And we'll use let's use an offset cut pattern. And we'll start on the inside, 25% step over, that would be fine. Let's do a cleanup pass at each cut level. And we're going to do a location of cut geometry is at top. Our total cut depth, we'll bring it down 1/2 of an inch to get through that bottom side. And we'll set this to 1/8 of an inch cut levels. Entry and exit, we'll use a helical entry. And we'll set our arc fitting, and let's do a generate. So you see what we've got here is a nice helical entry, and we got a cut level, circular cut cleanup pass at each cut level. Okay, so we got that hole done. Let's go ahead and do these outer holes. So we'll do some drilling. And we'll select our 1/2 inch. We'll do some pre-drilling. So let's select our center drill. And let's go ahead and select all of our holes. And for the feeds and speeds, we want to slow this down since it's drilling. Clearance, we'll leave that set to the default. Parameters, we're going to do a deep drill. We'll just come down 1/4 of an inch, and we'll set our increment, 2 pec increments at 1/8 of an inch. The location of the geometry is at the top, and we'll set a short dwell. And for sorting, we'll just do a minimum distance sort and generate. Okay. So now we've got a center drill for all of our drilled holes. So let's go ahead and do our final drilling, do another drilling operation. We're going to clear our selections with the space bar. We're going to use the 1/2 inch drill and drill these 2 holes on the front. And feeds and speeds, we'll change those. For the parameters, we'll use a deep drill, and we're going to go down 1/2 of an inch through this flange. The location of geometry is at the top, and we're going to do an increment of 1/8 of an inch, and we don't need any sorting. So let's go ahead and generate that. One thing I did want to do, though, you notice that it's going right to the bottom. So let's go back into here, and we'll add a tooltip to the drill depth. So that makes sure it gets all the way through the bottom of the part. Okay, so we got our 2 holes drilled on the front. Let's go ahead and add another drilling operation. And we'll select these 2 holes here. Same 1/2 inch drill, same clearance. Parameters, we're going to do a brake chip drill since we're going all the way through. And the thickness is 1.5 inches. Our geometry is at the top. And we'll set the step increment at 1/4 of an inch. And we don't need any sorting, so let's generate that. One thing I did want to do is I did want to add the tooltip to it, because this is a through hole. So there's our 2 drilling operations there. Now we want 1 more drilling operation for the back. For this operation, we're going to use our 1/4 inch drill, clear our selections, and just select these back holes. Feeds and speeds again, slow that down. And clearance is the same. Parameters, we want a deep drill, and we want to go through 1.5 inches, add the tooltip, and our location of cut geometry is at the top of the cut. And we're going to set our step increment for this at 1/8 of an inch. So let's go ahead, and we don't need any sorting, so let's go ahead and generate that. So here's our drill for the smaller holes. So what do we have left? We have a top face, we got a roughing, we got profiling on the front, we got parallel finishing in this pocket, we got profiling to finish the outer front of the pocket, and then we have pocketing for this center hole, and then our drilling operations. This is going to be held with clamps, so we don't want to cut all the way down on the outer perimeter, so we're just going to do it at a half height. So let's go ahead and add another profiling operation. For the geometry, we'll just use the bottom edge. We'll use the 1/2 inch flat end mill. And for the parameters, we'll leave the stock at 0. We're going to profile right up to the edge of the part. And for our cut levels, our location of cut geometry is we're going to do a pick top at 0. Actually, the pick top now is down negative 0.1. That's the actual top of our part. So we'll set our total cut depth halfway down. That would be about 80 thousandths. And we'll do a rough depth of 0.2 rough depth per cut of 1/4 inch. And we don't need the sorting. Entry and exit, we'll do lines and arcs. Apply that each cut level. We'll do a nice overlap to clean up any cut marks. And go ahead and set our arc fitting, and let's generate. So there's our profiling on the top half of the part. And let's go ahead and simulate that. And let's turn this around a little bit so you can see the cut overlap to clean up those tool marks. Let's slow this down a little bit. Okay, so we got a perimeter cut halfway down, and that's it for now. Stay tuned for more videos from MecSoft Corporation using VisualCAMc for Onshape.